Okay, in this video, we're going to be talking about Venn diagrams, and Venn diagrams are actually a great way of representing the some of the stuff in logic that we've been talking about. Our first Venn diagram, and it says Venn diagrams are a visual way of displaying the relationship between sets. The first Venn diagram here, you've got two sets, and I want to point out, notice something, that this set P is entirely contained inside this Q. So that means that everything that's in P is also in Q. So this is, it says all elements of P are also elements of Q. This is a great way of representing implication. If an element is in P, that implies that it would have to be in Q as well. So that is an example of implication. The next set, notice that there's some overlap here. That means that there's some things that are in both sets. Some elements of P are also elements of Q, and that would be these right here that are both in P and Q. So since it's in both, think about that, P and Q. That is a great way of representing your and, or as we called it in previous lessons, conjunctions. Now let's talk about disjunctions. What do we mean by a disjunction here, P or Q? Well, it can be in either. It could be in one, the other, both, at least one set. So if you say P or Q, it could be over here, it could be over here, or it could actually be in both. So an example of P or Q would be everything in P or Q. Again, P and Q would be the overlap region there in the middle. Okay, there is no relationship between P and Q's. That is two completely separate sets. There is nothing that's in both sets. They're completely separate from each other. Okay, so now let's talk about each of these situations, and let's draw a Venn diagram that represents each of them. Some students who take chorus also take band, so there's some overlap there. That's going to be that middle one. There is some that take both, so that would look like this. You have chorus, you have band, and then you have some that take both. That's all we have to do there to represent that. No perfect square numbers are prime numbers. That means that there is no overlap at all. So you have your perfect squares over here. We'll call them PS's. And then you have your prime numbers over here. And there is no overlap at all. They are two completely separate sets. So therefore, no perfect squares are prime. Number 3 says that numbers divisible by 3 are always divisible, or numbers divisible by 6 are always divisible by 3. So every number that's divisible by 6 is also divisible by 3. So here's your set of all things that you can divide by 3, and every number that's divisible by 6 is inside of that set. However, there are some other things in here. Let's talk about the stuff that's represented outside of that. That would be things that are divisible by 3, but not divisible by 6. And there are some numbers like 9. 9 would be a number out here that's divisible by 3, but not divisible by 6. Numbers in here on the inside would be like the number 12. That would be, hey, that's divisible by 6. That's the reason it's in this circle, but it's also in this circle because it's divisible by 3. Next set, every natural number. And anytime you see that every something is also something else, that's going to be a set within a set. So every natural number is a whole number. So these are all the natural numbers. And every one of them is a whole number. So that's going to be the set of whole numbers will contain inside of it all the natural numbers as well. Number 5 says some vertical angles are complementary. Not all vertical angles, but some of them, so there is some overlap. So let's draw a Venn diagram that has some overlap. So you have your vertical angles. There's all your set of vertical angles. Here's all of your complementary angles. And the ones in the middle would be the ones that are both vertical and complementary because there are some, is what it says. Some are vertical and complementary, and that'd be the ones in the middle. Irrational numbers are never. If there's never an overlap, then that's going to be two completely separate sets. This would be your irrational numbers. Irrational numbers. We'll just write that out. Irrational numbers are located over here. Your rational numbers are located over here. And notice that there is no connection between the two. There's no overlap. Number 7 says shade the indicated region indicated in the Venn diagram. So region Q. Everything that's in region Q would be everything that's in this Q circle. Okay, including the overlap. So this is everything that's in Q, is everything that's in that circle. Now, the stuff here in the middle, right here, is in Q, and it's also in P, but it's still in region Q. Next one, we want everything that's in region P and in region Q. The ones that are in the overlap, the and would be the middle part. This stuff is in P. This stuff is also in Q, so it's in P and Q. Number 9. Everything that's in P or Q. So this stuff is in P. This stuff is in Q. So everything that's in P or Q would be the combination of both regions. Everything in P or it could be in Q. Everything that is in P and not Q. The overlap, and again, reminder that this is an overlap. It has to be both. So we want to know everything that's in P. So that would be all of this stuff. And everything that's in not Q. Now let's talk about what not Q would look like. Let's actually do it in a different color. Not Q would be this part. This stuff is in not Q. Actually, everything out here is also in not Q. Everything that's not in the Q circle is in not Q, but we want everything that's in P and not Q. So that's going to be just the stuff that's inside of P, and that is not, because it has to be in both. So everything that is in P and is not in Q. So that would be the stuff that I shaded right here, that all this stuff is in P and this stuff is also not in Q. Okay, the directions on number 11 says describe each diagram using a conditional or a compound statement. And you see you have in the outside circle all acute angles. And inside of here, you have every angle that measures 60 degrees. Therefore, that would be an implication. If that would imply that since it's inside there, angles that measure. So if an angle measures 60 degrees, that implies that it is acute. And that's what we can write it like that, or we can write it as since it's an implication, let's remind you of what that means. Since it's an implication, we can write it as an if-then statement. And that's probably a better way of doing it, and that's what I've done here. If an angle measures 60 degrees, that implies, or then, it is an acute angle. The next one. If an animal is a beagle, notice that all beagles are inside of dogs. There's nothing that's a beagle that's not a dog. We already know that. So beagles here, if it's in beagles, that implies that it's in dogs as well. So let's write that as, that's an implication. Let's write it as an if-then statement. If an animal is a beagle, then it must be a dog. And that would be your if-then statement for that Venn diagram. Notice here that we're talking about the overlap. Notice that we've got overlap between volleyball and piano lessons. And one word comes to mind when I see that, and that's both. So some in the middle, some people play volleyball and, remember that, that's the and. Some people play volleyball and take piano lessons. Okay, number 14. Notice that you're talking about the stuff that is shaded. It says months with 31 days. And then this is months that starts with J. So this over here would be the months that have 31 days but are not. Notice that we're not talking about the stuff that is in this circle. So we're talking about the months that have 31 days but that do not start with the letter J. So this would be the months, again, the months that have 31 days that do not start with the letter J. And if you want to compare that with some stuff that we've been talking about, this is an and statement. This would be the stuff that is in 31 and that is not in the starts with J one. So that would be 31 and not this circle. Okay, the next one. Kind of the same as that one. We are in this circle and not in this circle. So these are all the art class people, and these are all the freshmen. And notice that there is some overlap. There are some people that take art that are freshmen, but these over here, notice that do not take art. So this would be all the freshmen, would be the whole circle, but the ones you're talking about are only the ones that do not take art, because these are all the ones that do take art. So what's represented by this would be freshmen who do not take art class. Okay, the next one. Notice it's an or statement. It's anything in this circle or it's anything in this circle. So anytime you have a combination like that, this would be an or statement. So these are all the numbers that are multiples of 7 in this one. These are all the numbers that are even numbers in this one. And there is some overlap here, but we're talking about every number here. So this is any number that's a multiples of 7 or that's an even number. There you go. And it's, again, I underline that or again because it is any of these or it can be any of these.